in the previous video, what you guys saw was measurement of length, mass and time, correct? The three fundamental. Now, guys, there are 7 fundamental units. Okay, there are 7 of them. Now, if you look at the table here, these are the 7 fundamental units. I think we have already discussed this, isn't it? It's just a recap. These are the 7 fundamental units. Now what you have is there are certain things called as derived units. Alright? Derived units are what? We use these fundamental units or the basic quantities and we get these other derived quantities. Alright? Simple example for that, let's take force, or even simpler one, velocity. What is velocity? Displacement over time. Correct? Now displacement is length and time is second. Basically, you're talking about length and time, isn't it? Now both are fundamental units. Same way, force if you take. What is force? Mass into acceleration. Now mass is a fundamental unit, but acceleration you can write in terms of length over time square, isn't it? So any quantity you take, any physical quantity you take, that can be written in terms of these basic quantities, isn't it? Now you have 2 types of quantities. In physical quantities, one is basic, one is derived, isn't it? Now, for all the quantities you see, physical quantities, most of them, they have dimensions, correct? Dimensions meaning what? They have units, SI units, isn't it? Now, whenever we have SI unit, we have something called as dimension. Okay. Now, dimension is what? You are writing a physical quantity, especially the derived ones, in terms of their basic units or basic fundamental quantities. Like I gave you an example of velocity, right? Meter per second. Meter is what? Length. And then second is time. Correct? You can write velocity in terms of length and time, isn't it? Now what you have is dimensional analysis. Alright, now when you say dimensional analysis, what we mean is whenever you have a physical quantity, how you can write it. Okay, how you can write or how you can represent, this is basically what we mean by the dimensional analysis. Alright, let's take the example of length. See, this is one of the fundamental units, correct? Now, let's take an example of, say, 10 meter. You are going a distance of 10 meter. Alright? Now, distance, whatever you are taking is length. We write it as L1. And do you have mass or time or anything? No, right? So, we write L1, M0, T0. We represent in terms of L, M, T. Or you can also write MLT representation. If you are writing in terms of MLT, it is M0, L1, T0. Alright. Now this is for length. Correct? Very simple. Now let's go a little bit further. Let's say you are talking about velocity. What is velocity? It is displacement by time. Correct? And displacement, what is the unit of displacement? Meter. So dimension becomes L1, M0, T0, correct? Divided by, for time, it is second, right? Which is L0, M0, T1. Now, if you look at it, because this is like normal division what you do. Division in the sense, remember the powers you use to divide, isn't it? Now, if you look at it, you get L1, M0, T minus 1. Because what is T power 0 minus 1? Normal exponent law. You get L T minus 1. Since M0 you don't write M0, you get L T minus 1. This is the dimension of velocity. Same way if you do for acceleration. Now what is acceleration or what is the unit of acceleration? Meter per second square. Correct? When you have meter per second square, meter which is L1, M0, T0. Correct? Second square, you are squaring the time. You get L0, M0 T2. When you look at this, you get L1, or you can just call it as L1 M0 T minus 2, or you can call it as LT minus 2. This is the SI unit of, or dimensional formula of acceleration, and SI unit is meter per second square. Correct? Now guys, there are, for every physical quantity there is dimension. Correct? Just like how you have SI unit, you have dimensional formula also, but not all of them you require it. What is important, you know, I'm going to show it to you in a couple of things here now, okay, in the video. Now these couple of dimensional formulas what you are going to see, these are important ones. Okay, now what I would say is, please go through them, make a note of it so that you remember these dimensional formulas. As you guys saw these dimensional formulas, now guys, these are the basic ones, you know, like what you use in most of the problems, and these comes in most of the topics what you will study this year. Okay, but there are a lot more which you guys will see at the end of this particular video. So you guys are going to get one information about these all the dimensional formulas and all the dimensional methods, whatever we have, methods of finding it, you guys are going to learn in the next video. But what are the dimensional formulas, you guys will see at the end of this video. Alright, now these are the couple of dimensional formulas.